The following program is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Oh, welcome back to Element 14 Presents. My name is DJ, and today I'm going to teach you how to become a master hacker. Let's get started.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
Depictions of hacking and the use of technology in general in TV shows and movies is often inaccurate, if not outright detached from reality. And while people like to give old media a lot of flack for this kind of thing, video games are just as, if not more, guilty of the same kind of ridiculous representations of technology and how people use it. But that's okay, it's meant to be fun, not realistic. And one of my favorite video game series that does this is Fallout, or at least Bethesda's version of Fallout. And one of the common mini-games they've created throughout the world is hacking, using dumb terminals found throughout the world. And this allows you to gain access to doors or control robots or shut down defense systems, that kind of thing. Now, in the Fallout series, their technology is a little bit different than our own. They, despite being in the future, never developed LCDs, so all displays are still CRTs, and the terminals look like this. They're huge, chunky, all-in-one computers. And if we're going to recreate that in the real world, we'll need to make some design decisions. Now, you might be wondering, hey, why don't you just use this cool actual serial terminal that really has monochrome green on black graphics? It's perfect. And you'd be right. I bought this years ago explicitly for this purpose. And while I could make that for myself, I want to make a version that you could make, which means using parts that people can actually buy, because things like this are becoming increasingly hard to find, if not just outright maintain. So in keeping things simple, I've decided to keep the parts count to a minimum. Here's what I've got that we'll need to make our miniature terminal. Okay, so let's talk about the components we're actually going to be using in this build. First, the display. I'm using a 3.5-inch LCD, which has a resolution of 480 by 320 pixels. This mounts directly on top of a Raspberry Pi, and I've decided to go with a Raspberry Pi Model 3 B+. For audio, I'm using this combination DAC and amplifier, and this communicates over I2S to the Raspberry Pi. And we've also got a miniature speaker to accompany that. Now, I've also got a microcontroller here, and I'll explain more of its function later, but it is necessary. For input, we're going to be using these tactile switches because we don't need a full miniature QWERTY keyboard, just some directional controls. For power, I've got a socket as well as a 2.5 amp at 5 volt power supply. And for power control, I've got this little power on-off shim, which is meant for a Raspberry Pi and makes it super simple to boot and shut down a Pi safely via a momentary push button. And that's it. Those are all the electronic components that we'll need to make our terminal. But before I solder them up, let's jump over to 3D Land to talk about the 3D model that this is all going to fit inside of. Okay, so here we are in Fusion 360, and I needed to choose the electronic components first before getting into the 3D modeling, because those are going to be our major design constraints when it comes to the shape and how we're going to 3D print everything. So what we're looking at now is the in-game object from Fallout 4. So this is the mesh that they would texture to make look like a terminal in game. And this is really useful for figuring out the proportions of everything and the overall profile. Now, you might think that we could just use this in 3D printed, but these kinds of mesh files are only useful in an artistic sense, but when it comes to solid modeling and making something 3D printable, it's entirely rubbish. So we have to recreate everything from scratch, and thankfully it's not too complicated of a design, so that's fairly straightforward to do. And I've gone ahead and scaled everything down to our first major constraint, which is the display and Raspberry Pi. So proportionally, I made the model around the LCD because that's what you're going to be looking at most of the time. One major difference being that the in-game asset, let's turn on that, is of course the more retro 4:3 aspect ratio, whereas the LCD we've got is not. And it would be nice to have a 4:3 aspect ratio LCD, but they haven't been made for quite some time, at least not in this size. So we'll just tweak things so that it looks right. So I'm going to turn that off. So starting from there, gone ahead and made our bezel. So this mates directly around the LCD, and the bezel mounts into the faceplate. And this is where we'll mount a lot of our little greebly components that don't necessarily do anything. So I'm going to turn that on. We've got this weird little plate and these knobs. I could have put some working knobs in there, but I would have had to extend them out to shafts, to potentiometers back there, and it just would have been a lot of extra work for very, very, very little gain. But it's something you could do. The options there, these just mount via screws. They're just little dummy bits. Here is the hollow tape slot, which is just about an inch wide, or 25.4 millimeters. So you could probably turn that into an SD card slot, but this is just a little peg bit that just pops right in there. And here is our grill for the speaker. And here are the cutouts for our buttons. So let me turn on the keypad. Now, one of the biggest differences between my version of the terminal and how it looks in game is, of course, the keypad. And to play the game, where you just need these directional arrows, so up, down, left, right, an enter, and a cancel button. This isn't necessarily a replica because it's meant to be a playable game and not a functional computer per se. And underneath there, so let me turn off the keypad and turn on the buttons. So all of those keycaps, I should say, mount over the tactile switches, and the tactile switches mount to this frame, which will rest in the case. So the overall case of the terminal is one singular part for strength and just simplicity of putting it all together. Now the face does mount into, it screws onto these mounting points right there. I didn't add anything special for the screws. Steel screws thread quite nicely into 3D printed plastic, so I don't need to do anything crazy there. And on the back, we've got the rear plate, which just has a vent, just like the in-game model. This is a cutout for the main push button, a cutout for the power socket, and a cutout for the USB connection for the trinket. So let's turn off the rear, and the trinket will just mount right there and connect to our Raspberry Pi. I didn't model everything because there's actually tons of space in here, and I know that I have plenty of room for all the extra components. There's not really going to be any conflicts, so we'll just have some wires coming from the buttons to the Raspberry Pi, and from the Raspberry Pi to the DAC and speaker right here. But other than that, there's not a whole lot going on inside of this case, which makes it nice and straightforward to build. All right, so let's get this to 3D printing. All right, as you can see, everything came out all right. We've got all of our parts, our little buttons, and the case itself. You'll notice it's actually really tiny in real life. It's only about 150 millimeters square at the base. Now, I'm just going to sand this up a little bit, and then we'll use some spray paint to bring it to a more game-accurate palette. All right, it's time to solder. So the first thing I'm going to do is actually attach this shim board to the Raspberry Pi. Now, it's thin enough so that we can wedge it in between the female headers of the LCD and the Raspberry Pi itself. And on the underside of the Raspberry Pi, we'll need to connect wires to the DAC and amplifier, as well as to the buttons and trinket board. All right, let's get started. Okay, here are all of the electronic components. One thing I realized halfway through is that, of course, you can attach wires to the breakout points on the back of the LCD board, which made it really easy to attach the buttons and the audio board, which means I didn't have to solder to the underside of the Raspberry Pi, which is a bit more finicky. And now everything is a lot more modular and easier to put together. Speaking of putting it together, let's do that. But wait, what about the trinket board? You mentioned you're going to talk about that later, and now it's that later time to talk about it. So the trinket is actually going to act as a USB human interface device and emulate a keyboard. When the hacking game is solved, one of the GPIO will be triggered, and that will type out our password for my shop computer. All right, so before we take a look at the code, let's take a look at the game itself, because I know not everyone has played Fallout and played this minigame, so I'll explain how it works. The premise is very simple. You have to find the password. You have 4 tries, and your options include the text in these 2 columns from this sort of pseudo memory dump. So I'm going to navigate with the arrow keys, and if I'm over a word, it will automatically highlight that word, and I can enter that selection. So, well, I got lucky, and that was the password. I'm going to cancel that. So let me go back. So if I go through and select a word, you'll see that the likeness will show up on the right. So I have a likeness of 0, which tells me that the password shares 0 characters in the same location as the characters found in our entry, which in this case was condo. So in addition to entering words, so guesses for the password, you might find open and close matching pairs of brackets. So I've got these parentheses right here, and if I hit enter, it will remove one random word that isn't the password. Alternatively, sometimes it will reset the tries. So that's just a little bonus mechanic that you find in the game to make it a little bit easier, although it's not particularly hard to begin with. So let me go through, and so hired, which has a likeness of 1, means that one of those character locations matches the password. So I'm not going to go through all of them, but since we got the password on our first try, let me enter in a word that is not going to work. So my attempts go down, and if I use my final attempt, we are locked out of the terminal. So I'm going to quit that again and open it one more time, and you'll notice that this is actually entirely within the terminal. Although it's graphical, it's not. There are no bitmapped graphics. I'm actually using curses, which is a module that allows you to create simple GUI interfaces in the shell. And since the RobCo terminals only have text-based graphics for the most part, this will work just fine for our terminal game. Speaking of which, let's take a quick look through the code. I'm not going to go over everything because there's quite a bit. And keep in mind, I'm not a software developer, and I'm still
learning Python. I've really only been learning for a few months, so things are not as good as they could be, but I'm happy that it works. All right, first things first, we need to generate these words that will populate our game. So I've got a list of the 10,000 most popular English words according to frequency or use. And what we're going to do is we're going to turn that into a list of words, and we're going to sort them by their length, because all of the entries have the exact same length. That's how we can match them and compare them. Because if they were different lengths, it would be way, way too easy. And this is how it is in the game. So we arrange our list of 10,000 words by length, and now that we've got blocks of different lengths of words, we can pull from that block of words so that we've got a population of words that we can put into our game. So this function is called by the main program. So we just have the number of words we want to populate and the length, which in general will correspond to the difficulty. All right, so over to the main program. One thing you guys will have to do some work on your own is to find these audio files. I can't give them to you because they're actual game assets, and I don't want Bethesda to get mad at me. I like them, but you can find them easily enough. So we've got our terminal game class, and the very first thing we do is make the data that you can actually select. So what I call the passwordgen.py really just sorts the text into the lengths of words, but we need to create all this information that you can choose from, which includes a bunch of junk characters and the words, and one of those words is the password. So that's what the data set is one continuous string that has all those junk characters, and then we populate the words evenly spaced throughout the data set, and we just keep track of where things are. Although one thing that does happen, the open and close brackets are just by chance, so I'm not explicitly creating matching pairs, so you could get unlucky and not have any bonus brackets, but I've never had that problem so far. So in the game, you actually have a cursor, but in the universe, mice don't exist. So presumably you don't mouse over everything and you're manually typing everything out. But since we're using just a keypad type layout, I just have it so that you use the keypad to cycle through the characters, which looks just fine. So that's all the update cursor is doing, is moving around our selectable text. We've got some helper functions to translate the location within our rows and columns to the actual terminal position, and this get index of selection is because we need to do some fancy formatting to figure out what to highlight if we want to highlight a whole word. We have our test function, which means when we're actually over something that we can highlight, like a word, we can enter that, and the game will just go through and test to see if that is like the password, or it will do one of the bonus functions like removing a dummy word or resetting the tries. And one thing that also happens too is we've got the side text, so every time you enter something, I might do that again. Every time you enter something, the text will scroll up here on the right, so that's what that does. And then we've got our main drawing function, which handles the graphical layout of everything right here. And you can take a bigger look into that. But it's not too long. It's only a few hundred lines, and I would love for someone to tear it apart and tell me how to do it better. All right, let's get to actually seeing this in the real terminal. All right, let's test this out. Okay.
Password elect. Likeness 1. Okay. Let's just try. To Chevy. There we go. And enter. And we're in. And that about does it for my tiny RobCo terminal. I love this thing. It's so little. I'm super stoked with how this came out. If you guys are fans of the game, you'd probably consider this a pre-war terminal because it's nice and new. So I'll definitely have to take some time and weather it to make it look like it survived a nuclear apocalypse. But other than that, I think I'll probably just redesign the keypad so they're a bit tighter and feel better. But it's playable. You can play the game, and this is just such a fun Raspberry Pi case. I hope you guys make your own, and if you want to, you can find the bill of materials, the 3D files, and my average Python code at element14.com/element14presents. Thanks for watching, and I will see you guys in the wasteland.